Hi, I am Uday Shankar representing Lab Electronics. Lab Electronics is a 40-year-old company, manufactures educational electronic training systems supplying to various educational institutions and defense establishments. Educational institutions like engineering colleges, polytechnics, ITIs, science colleges. In the defense, we supply these products to Army, Navy, Air Force schools. We also export our products to neighborhood countries like Sri Lanka, Malaysia, Singapore, and to most of the European countries, and also to African countries. Now, I am here to explain to you about this pneumatic trainer. Pneumatic trainer is a part of mechatronics. It is a mechanical devices are there with electronics circuitry involved. That's why it's called mechatronics. So this pneumatic trainer is a very interesting and very important subject for somebody to understand about robotics and motion studies. So here I would like to explain to you the components and elements that are involved in the pneumatic trainer. So I will explain initially. To begin with, I will explain about each and every component that is used in the pneumatic trainer. So let me start with, this is a single acting cylinder. This is a double acting cylinder. Here we have three varieties of operating the cylinders. The one is manually operating the cylinder. The second one is pneumatically operating this cylinder, that is through air. The third one is electrically operating this cylinder, that is by giving DC voltages of 24 volts. So basically we will be using valves 3x2 way, 2 sets, and we also will be using 5x2 ways for actuating these cylinders. Apart from this 3x2 and 5x2 valves, we also use AND valve and OR valve. Means to say, if both the inputs have got the air input, only then this output will be there, only then this cylinder will get actuated. Similarly, this OR valve, or if any one of the input is there, then the output will be there and the cylinder will get actuated. This is the concept of the AND OR valve. Similarly, we have 3x2 roller lever valve, direct actuator. Similarly, we have provided 2 sets, and we also have 5x2 double end solenoid valve. You have got 2 coils here, that is why we call this as a double valve, solenoid valve. And also, of course, not but the least, you have a pressure gauge to maintain the pressure at 3 bar. This air is just given from this compressor given below here. From this compressor, the air is built and the pressure is maintained through this gauge. Optimum pressure that we should maintain is 3 bar. So apart from that, to get the electrically operating the solenoid, we also have an SMPS, switched mode power supplies, which generates 24 volt DC. And here we have given limit switches. We have given 2 limit switches. Essentially, these are the components that are used in our pneumatic trainer. And we also provide you an instruction manual, step-by-step instruction manual procedures, how to build each and every experiment from the beginning. This will help in building complex pneumatic circuits. Yeah. In this, now I am going to demonstrate to you the first experiment, how a 3x2 valve, manually how you can actuate this particular cylinder. So now I am going to demonstrate to you using a single acting cylinder, manually 3x2 valve I will be using. So, initially to begin with, how I am going to do these connections, I will explain to you. What you have to do is, you have to use this tubes, air pressure tubes, just you press this and then you fix it. It's as simple as that. Now, when you want to remove that, just press this and remove it. So, this is the way you have to do the connections. So, now what I have done is, now I will be giving the air pressure and I will maintain the pressure using this valve and I will lock it. So, I will open it and then I will close it and then lock it at 3 bar. I will always maintain this 3 bar for optimum use of these cylinders. So, we always recommend to use 3 bar for this setup. Now, what I am trying to explain to you is, I will be using a single acting cylinder which has got one coil, and now that the air pressure is maintained at 3 bar, when I press this manual 3/2 valve, you see this stroke length. Now, I am going to demonstrate the use of single acting cylinder using the pneumatically actuated valve. The meaning of pneumatically actuated valve is, I will be using the air pressure to move the cylinder in forward and backward movements. Whenever the pressure increases to 3 bar slowly, you will see the forward movement of the cylinder. Now, I am going to increase the air pressure and I am going to lock it at 3. Now, you see the pressure is slowly increasing. Now, it is 1. Now, the pressure is 2. The pressure is 3. Now, I am going to lock it. You would have seen the cylinder moving in the forward direction. Similarly, now when I decrease the air pressure, you will see the cylinder will move in the backward direction. You can see this moving. This is how the cylinder is actuated using the air pressure, that is pneumatically actuated valve. 3/2 way pneumatically actuated valve we have used. Yeah, this is the third experiment which I would like to demonstrate. The third experiment is, again we will be using the single acting cylinder, but instead of that we will be using 3-way single solenoid valve. This is a solenoid valve where it is electrically actuated. It has got 24 volts and ground. So, this is a electrically actuated valve, means to say that you can give a DC supply to actuate this particular cylinder. Now, what I have done is, we have taken this 24 volts from this power supply, 24 volts. This is a power supply bank is available. So, 24 volts, and another one is the ground terminal I have used. See, basically I have given supply and ground to this electrically actuated valve, and now I am going to demonstrate using a limit switch. The idea of using a limit switch is as a matter of protection, and also I wanted to highlight how a limit switch is used in the context of pneumatics. So, I will just demonstrate how it works. This is a limit switch. When I actuate this limit switch, you can see that it is moving. I am pressing, leaving, pressing, leaving. This is the limit switch. We have provided two limit switches. So, I have used one limit switch to operate the single cylinder. When I press it, you can see the cylinder moving in the forward direction. When I release it, it is moving in the backward direction. So, this is the third experiment, very important experiment in the pneumatics. Basically, we have covered all three types of sources. Like one is manually, first experiment, the second one is pneumatically operated, the third one is electrically operated. So, in effect, there are only these three types of ways of activating the cylinders. Yeah, now I am going to demonstrate the fourth experiment. Here I will be using a double acting cylinder. It moves forward and the reverse direction. And I will also be using the manual operated valve using 5/2 way. So, this moves forward and direction as and when I manually switch. This is how the double acting cylinder works using 5/2 way of solenoid valve. So, this completes all the four basic experiments, and we will also be giving you a detailed instruction manual explaining various combinations of activating these two cylinders using various valves, electrical valves and also mechanical valves and pneumatic valves. And in each experiment we will give a patching diagram. So, by looking at it, you will be able to perform all the important principles, all the important experiments in the pneumatic trainer. I hope you have enjoyed our demonstration, and we feel that this will give an insight into the learning of pneumatics and its elements for industrial applications. Thank you.